So welcome back to STEM Baba, where this video will be winding up the remaining questions for the chapter 5, and also with this video season 1 will be completed. Okay, so we'll be discussing couple of problems related to this passage. So an automobile accident is succession of 3 separate collisions. The first one, the automobile collides with an obstacle and comes to rest. The second one is the people within the car continue to move forward until they collide with the interior of the car. Third one, organs within the occupant's body continue to move forward until they collide with the body wall and brought to rest. So here we see that nothing can be done for the third collision, but the effects of the first 2 collisions can be reduced by increasing the distance over which the car and its occupant brought to rest, and hence reducing the force that acts on the occupant. Okay, now the first collision can be reduced by building crumple zones into the body of a car, and the second collision can be reduced by the use of seat belts and airbags. So this figure shows the stopping force versus stopping distance. So here we see if you are traveling with speed say 36 meters per second and your weight is 65 kgs, then if you are stopped over a distance of 1 meter, then the force, the stopping force required would be near about 50,000 Newton. But if you are traveling with a speed of 18 meter per second and you are brought to rest within 1 meter, then your stopping force would be near about 10,000 Newton. So this is the data that we are given. Now let's discuss couple of problems related to this passage. So this is the first question based on the passage problem, and it says that by using the combinations of crumple zones and airbags, we are able to increase the distance over which the car stops, and the distance is increased to 1 meter. Now our aim is to find the magnitude of the force exerted on a 65 kg driver who decelerates from 18 meter per second to 0 meters per second over a distance of 1 meter. So first let us find the acceleration, or in this case the deceleration. So this is the direction for the driver, and initial velocity is 18 meter per second and the final velocity becomes 0, and the distance over which it becomes 0, delta x, we have 1 meter. So we can use the kinematic equations here, and we can write that acceleration will be equals to the final velocity square minus the initial velocity square divided by 2 times delta x, right? And this direction I am taking to be positive x. Now if you put the values, we'll get final velocity becomes 0, initial velocity we have 18 and it's squared divided by 2 times delta x, we have 1 meter. And if you solve this, you'll get this acceleration to be negative 162 meter per second squared. Now from here we can easily find the force. So by the Newton's second law of motion, we know that net force we have mass times acceleration. So mass for the driver is 65 kg. So 65 kg times acceleration is negative 162 meter per second squared, and this will be equals to 1.05 times 10 to the power 4 Newton. This is negative, and this is near about 10,000 Newton. And if you see this graph, we can compare the results. Like here the body was traveling with 18 meter per second and the speed was reduced to 0 within 1 meter, and if you see the required force, it is about 10,000, and the same value we have obtained numerically. So we can compare the graph also. Okay, in the next question it says that the initial speed for the driver is doubled to 36 meter per second and the mass is still remains the same, that is 65 kgs, and it comes to rest in 1 meter. Then what would be the force exerted on the driver during the collision? So initial speed this time becomes 36 meter per second and the final speed is 0, and it becomes 0 over a distance of 1 meter. So same procedure we're going to follow. First we can find the acceleration. By using the same equation, this is v square minus v naught square divided by 2 times delta x. So this is 0 square minus 36 square divided by 2 times delta x is 1 meter. So if you solve this, you'll get this value to be negative 648 meter per second squared. Now we can easily find the force, required force to stop the driver from its initial speed to 0. So this would be mass times acceleration. Mass is 65 kgs and acceleration we have negative 648 meter per second squared. And if you solve this, you'll get this value to be nearly negative 4.21 times 10 to the power 4 Newton. Now if you compare this with the graph, here we see that if you're traveling with 36 meter per second and you are stopped over a distance of 1 meter, then the required force is below 50,000, and this value is nearly 42,000. So we can see that we have obtained the correct result. And if you see the options, this option is correct, this one, the D option. Now to solve this problem, we have to refer the example 8, and this example I have discussed earlier. This was example 8. Here it was given that we have two blocks that have mass 10 kg and 5 kg, and a force of 30 Newton is applied on this block 1. And our aim was to calculate the contact forces, and we calculated contact force to be 20 Newton. Now let's get back to the question. Now in this problem it says we would like that contact force between the boxes to have a magnitude of 5 Newton. So contact forces between the block 1 and 2, it should be 5 Newton. There we calculated the contact force to be 20 Newton, but here we want that it should be 5 Newton. And the only thing that we are allowed to change is the mass of box 2. So this mass of box 2 is changed. Mass for box 1 remains the same, that is 10 kg, and the force applied is also same, that is 30 Newton. Now in the A part we need to tell, should the mass of the box 2 be increased or decreased such that this contact force becomes 5 Newton. We know that the contact forces between the boxes is responsible for accelerating mass m2. So if you see the free body diagram for the mass m2, this is mass m2, it accelerates in this direction with some acceleration a, and this contact force is 5 Newton. So here we see that this contact force is responsible for accelerating this mass m2, and if we increase this mass m2, then this force required will also be increased. But actually this the contact forces that we calculated in the example, it was 20 Newton. So this contact force is reduced to 5 Newton. Thus this mass should also be reduced. Thus we can say that it should be decreased. So for the A part, the answer is that mass m2 should be decreased. Now next in the B part we need to find the mass for the box 2. Okay, let's see. So first we have to calculate this acceleration a, and then we can easily calculate the mass m2 by using the Newton's second law of motion. So if we consider the free body diagram for the box 1, here we have 30 Newton force that we are applying, and the contact force is 5 Newton that we want. And by using the Newton's second law of motion, we can write that the acceleration will be net force divided by the mass, and mass for this box 1 is 10 kg. So net forces we have 30 Newton minus 5 Newton and divide by 10. So that would be 2.5 meter per second squared. This would be the acceleration. Now the acceleration would be same for the mass 2 also. So this is m2 here. It is accelerating with a to be equals to 2.5 meter per second squared. This force is 5 Newton, the contact force on the mass 2, and from here we can easily find the mass 2 m2 to be equals to the contact force, which is 5 Newton, divided by the acceleration 2.5, and that is equals to 2 kgs. Thus, if you consider this example, here the mass was 5 kg. Now the mass is reduced to 2 kg because the contact force is reduced. Here the contact force was 10 Newton. Now it becomes 5 Newton. So the mass for the second box also reduces to 2 kgs. So this is the answer for the B part. And in the C part, we need to find the acceleration of the boxes in this case. So acceleration we already calculated. It is 2.5 meter per second squared. This would be the answer for the C part. Now to solve this problem, we have to refer the example that we discussed earlier. And this was the example that we discussed when we were discussing the force in 2 dimensions. And here the force F1 was 26 Newton and force F2 is 41 Newton. And we calculated that net force will be 51 Newton and the direction is 32 degrees above the horizontal. And the acceleration also we calculated. So, but in our problem, we are given that this force F2, which was 41 Newton there, it is increased to 55 Newton and rest everything remains same. This theta remains 52 degrees. F1 is also 26 Newton. Then what we have to tell that do you expect the direction of satellite's acceleration to be greater than, less than or equals to 32 degrees. So this was the angle that we calculated in that example. The acceleration for the satellite was 32 degrees above the horizontal in that example. But in this example, when this force is increased, then we have to tell the direction of satellite's acceleration to be greater than, less than or equals to 32 degrees. Now if you find the direction of acceleration, you will see that it will be greater than 32 degrees. Why? Because the magnitude of this force F2 is increased to 55 Newton, and if you compare with the increase in y component, if you see sine 52 degrees, this value is greater than cosine 52 degrees, and hence the y component of the F2 force is increased more as compared to the x component, and thus the angle will be greater than 32 degrees. Now let us prove this by solving the B part, where we need to find mathematically the direction of the satellite's acceleration. So let us first find the net forces along the x direction. Sigma fx, this would be 26 Newton plus 41 cosine 52 degrees. That will be 60 Newton. And the net forces in the y direction, this will be only the y component of this F2 force. So 41 sine 52 degrees, which is equals to 43 Newton. Now the acceleration AX, we know it is the net forces in the x direction divided by mass. So in the x direction net forces we have 60 Newton, and the mass we have, the mass for the satellite, it was given in that example to be 940 kg. So this is 0.064 meter per second squared. Similarly, AY will be sigma Fy divided by mass. So sigma Fy we have 43 Newton divided by mass is 940 kg, and that comes out to be as 0.046 meter per second squared. Now we can easily calculate this theta from here, and this theta would be tangent inverse AY over AX. So tangent inverse AY we have 0.046, AX we have 0.064, and that is equals to 36 degrees. Thus we conclude that the theta increases to 36 degrees. And next we have to find the magnitude of the satellite's acceleration. This is very simple. The magnitude for the acceleration will be a to b equals to under root x component square plus the y component square. So under root x component we have 0.064 and it whole square plus 0.046 and its whole square, and if you solve this, you'll get this value to be 0.079 meter per second squared. So this would be the answer for the C part.